All right, welcome back. This is Mark Summers again from Summers Technical Services. Successfully got the simulation to finish up. It took a whopping 24 seconds. So this is the summary sheet that you'll get. You can monitor your status as you go. So there's the total CPU time, 24 seconds. You can see how many elements you have. Total cells, 11,000. Fluid cells, 11,000. And breaks that down for you. And it's got some other useful information. It tells you, what kind of computer you're running on. So there's lots of other options in here that we'll talk about another time, but that generally just lets you know the thing's running. And so once it's finished, what it does is it creates a new folder. Let's pull that over here. It creates a new folder. Where did it go? Inside your where your models are. Here's all the models I've got, and it just makes a folder called 1 for the first analysis, and this has got all the answers in it, and you don't have to know what all these files are. I don't know what they are, but it keeps track of them for you. The key is don't monkey with any of these files. Just leave them where they are, and if you put this on a new computer somewhere, you're going to want to grab all these files and these folders, otherwise the simulation won't go along with it. So it does a good job of managing all those files. You don't really have to keep track of that stuff. So once it gets through running, there's a results tab down here, and I can right click. It's loaded right now, 1.fld. That's that folder we just looked at. And so if I right click and unload that results, now it's not loaded, and so there's nothing down here. When you save and close and open it back up, it'll look like this. So when you open it back up for the first time, you have to say load from file, and it'll load the results back up. And you can have multiple different analysis with the same assembly model, and they just store them under different folders. So like I said, it does a really good job of keeping track of all these files. All right, now we got all the answers. Now let's go ask for them. And so let's go through a few options here, and then you can play around with these. Best way to learn this stuff is to do it. So I'm going to go to flow trajectories, and I want to insert a new defined flow trajectory. And I'm going to use the click point option, and I'm going to spin this thing around. And I want to see what the points that enter the fan, I want to see where they end up progressing to. And so I'm going to select that face, and I'm going to click on pick points. And I'm not going to be too careful. There's multiple ways to enter these things, but I'm just going to click a few here. Catching up here. Here we go. So I'm just clicking on the screen, putting some points here that I want it to trace out through my flow. And maybe that's enough. All right, I want to define, there's lots of options down here. You can play around with this. I don't want, I think I want velocity. I want to map the velocity of those points. And so I'll agree with that and say OK. Once it comes back to life here. There we go. And it creates these trajectories, and it gives you a nice little legend up here that tells you what the different colors, what kind of flow rates. And I was able to find that units thing. I'm going to go show you where I found that. So I'll right click on input data, go to units, and somewhere down in here it had volumetric flow rate. Now I'm not going to be able to find it again. It's in here somewhere. Poke around in here and find it. But I changed it to cubic feet per minute, and that's what it's giving me. Oh, excuse me. Velocity is in feet per minute. And so there's the values. And the blue is slow. And that's just this air floating around out here. And then it shoots through and speeds up. And if I want to animate this thing, I can right click on flow trajectory 1 and say play it. And I get a little visualization that shows me what's what's what. And so that makes sense. The fan's blowing in the correct direction at least, and all the air seems to be blowing out the end. There's no leaks. And so that's useful. So I want to hide that or stop it. And I stopped it, and I'm going to hide it. And now maybe the next thing I'll show you is cut plots. And this is just extracting the data. Let's hide that. And so maybe I can do a cut plot through here and find out what the velocities are at a certain station in here. And so I can come up here and grab, I'm going to right click on cut plots and say insert. And once it comes back to life here, I'll zoom in here and I'll drag this thing. Maybe I want to see what the, oops, give it an offset maybe of 4 inches. And I'll ask for velocities or pressures or temperatures. There's no heat, so this temperature is going to be 70 degrees everywhere. Let's just look at velocity, overall velocity. And did it give me an offset? Yeah, it offset it right there. So that might be interesting to look at. So I'll say OK. And I need to hide my duct so I can see what the air is doing. So I'll right click, temporarily hide the duct, and now I can get a profile of what my velocity is doing inside each one of these ducts, and I can get a feel for what's going on. And maybe I got some high velocity here and some low velocity here, and so maybe I need to redesign my duct to get a better consistent flow through that opening. All right, so let's go back to flow simulation. I'm going to turn the cut plot off. We'll hide that, and now what am I going to do? Let's look at these goals. So I'm going to go down here again to results. So I've made a flow trajectory. I've made a cut plot. And I can rename these things if I want to rename it something that is more memorable than just cut plot 1. So I'm going to hide that thing. I already hit it. All right, so now let's look at goal plots. And so I'm going to go back and turn on my duct here just so I can know it's there. And I'm going to do these goal plots and find out what that volumetric flow rate, that's really what I want to know, what that volumetric flow rate is coming out of those ducts. So I'm going to right click, unhide him, go back to the flow simulation tab, and right click on goal plots under results. And insert, and I can ask for these one at a time, or I can ask for all of them. And as I was thinking about it, I really should have split these up. I'd like to know how much flow rate is coming here and how much flow rate is coming here. So I should have made 8 of these instead of just 4. The pair is nice to know, but I'd like to know if there's more flowing on the outer ring than the inner ring, because I want to balance that flow as I optimize my duct design. But I asked for those, and so I'll turn all those on, and I can either show it or I can export to Excel. Export to Excel is awesome. It pulls everything into a giant spreadsheet, and I can go look at all the data across all of those goals I asked for. And so this one, if I remember correctly, this is the overall inlet, and so 139 CFM. And then each one of those pairs of openings has about 32 or 33 CFM coming out of each pair. And so if I add all those up, it adds up pretty much, what does it say down here? Sum is 132, 139. And so there's a disconnect between the flow coming out the end versus what goes in. That just means I need to refine my mesh to get up those should be closer than that. And so there they are. There's the values, average value, min, max, as it's progressing through the iterations. So you can ask for it that way, or you can also ask for it, just say show, and it pops it on the screen here, and I get a summary here. There's my 139, my 33s and 34s. And so that's how you can use those goals to extract your data you're looking for. And so if you forget to set the goals up before you run it, you actually have to run it again before you can ask for those goals. But you can always ask for these cut plots. You can make those surface plots, and there's a lot more I haven't gone through: particle studies, surface parameters, surface plots, ISO services. All of these are really, really cool. And depending on what it is you're doing, if you're doing thermal analysis, and I've got a heat sink in here, we'll do on another video, surface plots are good. You can ask for the surface temperature and it'll give you a nice contoured plot. So anyway, hopefully that was helpful, and you can do some kind of a flow simulation, and you're welcome to run this duct and see if you can't match my numbers, and probably should run it again at some higher meshes. So that should give you enough to get started. If you ever have any questions, don't hesitate to stop by and visit. Till then, we'll talk to you later.